Welcome back, everyone. We have one more example that I want to work through where the inside function is the inverse trig function. And then once we've done that, we will look at some examples where the outside function of a composition is the inverse trig function. So here we want secant of tangent inverse of 1. And of course, what I'm going to do, same as before, let theta be the inside inverse trig function. Let it be tangent inverse of 1. And so that means that when we're looking for secant of tangent inverse of 1, we will be looking really for what is secant of theta. And I'm already thinking ahead that once I find what theta is, and once I think about evaluating secant of theta, I would use the fact that secant is the reciprocal of cosine. So actually what I'll be calculating is what is cosine of theta, and then I'll take the reciprocal of that, and that will give me secant of theta, which is the same thing as secant of tangent inverse of 1. So the next thing for me to do is try to evaluate what is theta. And I know if I'm thinking about tangent inverse of 1, that is something that comes from a special triangle. Remember that for our triangle where the angles are 45 and 45 and 90, that the side lengths are 1, 1, and root 2. So if you were looking for tangent of 45 degrees, that would be opposite over adjacent, which would be 1 over 1. So we know then that the angle must be 45 degrees, or pi over 4. Now here we're looking for tangent inverse of 1, and we need to remember that, of course, tangent, we were restricting its domain to the same domain we were using for sine, which was quadrants 1 and 4, between negative pi over 2 and pi over 2. And so I know that the quadrant where tangent is positive here would be the quadrant 1. So my angle is going to be 45 degrees, the angle in quadrant 1, or pi over 4. So I can now say that theta must be pi over 4. And we are now good to go, because what we want to do is find out what is secant of theta, and we know that theta is pi over 4. And remember, I'd said previously that when we find secant of theta, that I'd be doing that by finding instead the reciprocal of cosine of theta. So let's do that. Let's find first cosine of theta. And for cosine of theta, we are looking at our special triangle with pi over 4. So that's the one we've got right here. Cosine of pi over 4 would be adjacent over hypotenuse, 1 over root 2, which is, of course, in simplified form, root 2 over 2. But if you're thinking about then what is secant of theta, it should be root 2 over 1. Instead of adjacent over hypotenuse, it should be hypotenuse over adjacent. So we can say that secant of theta should be root 2 over 1, or just root 2. So that means that secant of tangent inverse of 1 is root 2. There we go, lovely. Now, let's take a look at a couple of other things. So here we have the inverse trig function now on the outside. And this in a way is a little bit easier because remember, when we're looking at a composition of functions, we always evaluate working our way from the inside out. So if we're looking at something like sine inverse of cosine of 0, you would need to first find what is cosine of 0. And we've had lots and lots of practice all during Chapter 7 of evaluating trig functions. So we know that there's going to be two options. Either you can find the exact value of that trig function, and here you can. Cosine of 0, you can evaluate that. Cos of 0 is 1. And so that means then when you want to evaluate sine inverse of cosine of 0, you're really evaluating sine inverse of 1. And then now you just have to do the same sort of work that we've been doing all along in 8.1, evaluating an inverse trig function. The other option is if you don't have the number that's on the inside being a nice number for which you can evaluate cosine. So for example, if it was instead of 0 or pi over 2 or pi over 3 or pi over 6 or pi over 4, suppose inside the angle was pi over 7, and I can't find the exact value for cosine of that or any trig function of that, well, that's where your calculator comes in. Now, for that, that's even easier because all we have to do is enter into our calculator what we want. Now, there is the one caution here, which is, of course, our calculator has to be set in radians mode because you are going to give it an angle in radians. That's what's going inside the trig function. And when it evaluates the inverse trig function, it's going to give you an angle back in radians. So that's the only thing where we have to be a little bit careful here, is that when we're evaluating one of these composition of functions where the inverse trig function's on the outside, if you do need to use your calculator, calculator must be in radians mode. Okay, so first problem, we are looking for cosine inverse of sine of 7 pi over 4. And so just going to do a little quick sketch here. 7 pi over 4, that would be in quadrant 4. And I know that because 2 pi, a full circle, that is 2 pi is equivalent to 8 pi over 4, so 7 pi over 4 is just a little less than a full circle, and the leftover amount, my reference angle, should be pi over 4. We're talking about sine of 7 pi over 4, and I know that the quadrant that we're in, which is quadrant 4, it's cosine that's positive, sine should be negative. The other thing that I know is that for 45 degrees for that reference angle, that the side lengths for that special triangle are 1, 1, and root 2. I know that sine of pi over 4 is 1 over root 2, or same thing as root 2 over 2. So I know then that sine of 7 pi over 4, that it shouldn't be root 2 over 2, because we know that we're in quadrant 4, and that's where sine is negative. It instead should be negative root 2 over 2. So I've evaluated the inside function. I know now sine of 7 pi over 4 is negative root 2 over 2. So the thing that we're looking for, cosine inverse of sine of 7 pi over 4, is the same thing as, oops, not enough brackets. There we go. Is the same thing as cosine inverse of negative root 2 over 2. Okay, so now we just have to evaluate that inverse trig function. What is cosine inverse of negative root 2 over 2? I'm going to just go back for a second to my special triangle. I know that for cosine of 45 degrees, it would be adjacent over hypotenuse, 1 over root 2, or root 2 over 2. So I know that the angle that we're talking about here for cosine would also have the same reference angle of 45 degrees. But I also know that the angle that we're talking about isn't going to be in quadrant 4 or in quadrant 3, because we're talking about cosine inverse, and cosine inverse has a range of quadrant 1 or quadrant 2. And since we're looking where the number is negative, cosine inverse of negative root 2 over 2, that should be the quadrant where cosine has negative values, which is quadrant 2. So when I draw my reference angle, I'll be drawing it in quadrant 2. So there's my pi over 4, which means that the angle that I'm talking about must be 3 pi over 4. So now, to answer the final question that I have, what was cosine inverse of negative root 2 over 2? Well, it must be 3 pi over 4. So that means we can now say final conclusion. Therefore, cosine inverse of sine of 7 pi over 4 is 3 pi over 4. Lovely. Okay, let's go on and do one more example. And this one is one where, and I guess spoiler alert, we'll be using our calculator. The reason I know that we'll be using our calculator here is because I'm looking at the inside function secant. It's secant of pi over 7, and I know that that's not an angle that I have a nice special triangle for, so I guess it's calculator time for me. A couple of things though. First thing, and just to zoom in on my calculator a little bit bigger here, remember that your calculator tells you at the very top whether you're in degrees or radians or gradians, and we want to be in radians. So if you were looking at your calculator and it looked like this, DEG, you would need to press the DRG button, that's the button that changes it from degrees to radians to gradians, press it until at the top you see RAD, you see radians. The second thing I want to point out with our calculator here is that we only have functions sine, cosine, and tangent. So if you're looking for secant, which is part of what we're looking at, you would have to use the reciprocal of cosine instead. You would have to do 1 divided by cosine instead of putting in secant, which is what we want. And the one last thing just to mention before we get into the calculating is that for the inverse trig functions, those are found just using the second function and the trig function that you're looking at. So when we're looking for tangent inverse, we would be touching second function tan to get the second inverse function for tangent. So let's write down what we're looking for. We are looking for tangent inverse of secant of pi over 7, which I'm going to be thinking of that as tangent inverse of 1 over cosine of pi over 7. So when I'm thinking about entering that into my calculator, the things that I'm going to have to enter will be a couple of things. Number one, I'm just going to bring this up. I'll have to enter in, first off, tangent inverse. So I would do that as second function tangent. So now it's tangent inverse. And I want to put brackets because, of course, I want brackets around the 1 over cosine. So I would have bracket 1 over cosine. That would be 1 divided by cosine. And then we'll need brackets again. So bracket again, pi divided by 7, that's pi divided by 7, and then close our bracket, and then close our bracket, and equals. So, of course, remember to make sure that your calculator is in radians mode first. So just to go over that again, we are going to push, if we wanted to enter this in, tangent inverse, second function tangent, left bracket, 1 divided by cosine, another left bracket, pi divided by 7, close your bracket, and equals. And when I ran that through my calculator, I got about 0.837446 and some other stuff. And here we were told at the beginning to give 3 decimal places if we were using our calculator, so I will round that off to 0.837. And there we go. So we've now evaluated tangent inverse of secant of pi over 7. All right, great work everyone, and I'll see you shortly for section 8.3.